Okay, time for another force diagram. So what is our object? Identify the object. So here is the situation. I've got a ceiling. Attached to that ceiling is a rope. There's my favorite box in the whole world from Hazen High School is right here, hanging from the rope. I see that the mass is 50 kilograms. And then, this is my attempt to draw a monkey. There's a monkey hanging from the box. That's weird. Now, the monkey is a lot more interesting than the box, but the monkey is not the object. So the object is this box. And of course, nothing's moving, right? So we know the acceleration of my box is 0. The acceleration of the monkey is 0, but the object is the box. Done. Do a force inventory. All right, let's do a force inventory. Force inventory. What are the important forces, the meaningful forces that act on the box? Let's list out a couple that aren't meaningful. Okay, this box is being pulled by the planet Mars with a force called gravity because Mars, which is pretty far away, and both Mars and the box have mass, and all matter, objects with mass have matter. That's what pull on each other. But that force is way too tiny to worry about, so I'm going to completely ignore it. Also, this box is surrounded by air, and it turns out that the surrounding air provides a buoyancy force. But it's tiny. It's too small to worry about. Okay, if this box was in water, that would be a different story. Water is a lot more dense than air, so the buoyancy force of water can often have a big impact. Okay, so we're not going to include those forces. We're only going to think about the big ones. Okay, well, the first one I always do is gravity. Gravity from what, though? Not, okay, this one's going to be gravity from the Earth. And I see that the mass is 50 kilograms. So it's pretty easy to go from mass to weight, right? You just times 10. So 50 kilograms times 10 newtons of gravity force per kilogram is 500. So there's 500 newtons of gravity force, and that's going to be down towards the center of the Earth. Okay, so now I'm going to be thinking about what else is touching my box. Because gravity, I didn't really talk about this earlier, but gravity, the Earth doesn't have to be touching things to be pulling on it, but everything else pretty much does. So I see that I've got a rope pulling up, and I've got a monkey pulling down. That's weird. All right, let's do the monkey. So the monkey is pulling down. So we have a name for pulling forces, and that name is tension. So the monkey is exerting a tension force on the box. Now, how big is that force? Now we're going to use the monkey rule. It's basically similar to the elephant rule, except it's for things that are hanging from your object. The elephant rule was for when things are sitting on top of your object. The monkey rule is when something is hanging from your object, but it's kind of the same idea. Is that the monkey rule says that if this monkey weighs, and I'm just making up a number here. Well, I guess it could be our monkey. Sure, why not? What does our monkey weigh? 20 kilograms, that's not its weight, that's its mass. So we do 20 kilograms times 10 newtons per kilogram, and that's going to be 200. So, which is kind of like 30 pounds. So if the monkey weighs 200 newtons or around 30 pounds and it's not falling, it's going to pull down on whatever it's hanging from. So it's going to basically have a tension force. It's going to, I don't want to call, I'm going to erase that last thing there because I don't, no, come back. Okay, I want to get rid of that. And I think I'm going to. Okay, it basically pulls down on whatever it's hanging from with force equal to its weight. I guess you could say that is a tension force. Pulling is always going to be tension. That's the monkey rule. Sounds a lot like the elephant rule because it's kind of based on the same thing. the monkey isn't accelerating. When it's not accelerating, it's going to pull down on whatever it's hanging from with a force that's equal to its weight. All right, so we now know, using the monkey rule, we now know how hard the monkey is pulling down on my favorite box in the whole world, my Hazen 50 kilogram box. Okay, so our monkey weighs 200 newtons. It's going to pull down on the box with 200 newtons. So that's a down force. Now, there's another pulling force, and that's from the rope. Okay, the rope is pulling up on the box. Pulling forces are called tension. So that's going to be the rope. Now, there is no rope rule, so I've got to kind of say, I don't really know what that force is, but I know it's going to be up because nothing is falling. If the rope wasn't pulling up, the box and the monkey would be falling to wherever the ground is. Okay, I'm done with my force inventory. So step 3, represent your object as a dot. Well, when I have multiple up and down forces, meaning more than one, well, I'll give you 2 options, okay? 2 options. Since basically one option is to draw like a oval, like a dot like that, that's kind of squished out so you have room to draw your forces. That's normally what I do, but this time I don't feel like doing that. I just feel like drawing the little box. So that's what I'm going to do. It doesn't really matter. You just need a place to start making your arrows. Okay, so I'm going to go now. Step 4 is draw arrows to show the known forces. I have 2 forces that I know the size of. Okay, I'm going to pick the biggest one so I don't make my arrows crazy long. So gravity is 500 newtons. I like to do gravity in red. Not sure why. Okay, so there's my, I'm going to make it a little longer. Okay, there's, I see already my rope arrow is going to be, so I'm going to, since I decided to make my gravity force longer, I got to make this lower so I got room for my up forces. All right, so this is going to be gravity, which we use W for weight, and it's going to be the earth pulling down, and it's going to be 500 newtons. That's kind of a little over 100 pounds. Okay, so why am I keep telling you this stuff in pounds? Well, because, you know, we don't use newtons very often in everyday life. So I don't, you know, you tell me like, oh, how much force is 8,000 newtons? I got to, well, I have to always kind of think about it in pounds because it sounds big, but it's not as big as pounds. Okay, now there's another down force. The monkey is pulling down with 200 newtons, so not quite half, right? So I'm going to make that a blue arrow, and I'm going to make it a little bit less than half because 200 newtons is a little bit less than 500 newtons. And so that's going to be a tension force. I think this is our first tension force. So we use capital T for tension, and then the monkey is the one doing it. And I know that it's going to be 200 newtons. Okay, done with step 4 because every other force I don't know. But I think maybe you're starting to see that this is pretty, we kind of do know the tension force in the rope, or we certainly will soon. I know that the rope is pulling up on the box. Don't confuse it. The rope is also pulling down on the ceiling, but what is the rope doing to our object? It's pulling it up. How much force do I need? Well, this is again where we go back to this idea of the box is not accelerating, so the net force must be 0. Which means I need as much up force as I have down. So how much down force do I have? 500 from gravity, 200 from the monkey, that's 700. I need 700 newtons of up force because I see this, no acceleration, the total force has to be 0. So here we go. Oh no, not pink. Let's make it green. All right, that's the tension. And that's going to be from the rope. And let's see, so yeah, 500 plus 200 is 700 newtons. Okay, we're done. There's our force diagram for our box.